Cool guys, so in this video we'll be looking at simplifying expressions by adding and subtracting and multiplying. So now let's look at this thing called like terms. I'll write it out for you. Like terms. And we always talk about you add and subtract like terms. Sorry, my K is a bit weird there. So we always add and subtract like terms. Well, like terms, we're pretty much saying has the exact same variable and the same power, or in other words, the exponent. Okay, the coefficient in front of the variable does not matter. If that doesn't match, that's fine, but the variable and the power must match. So let's look at an example of this, of adding like terms. Okay, so let's look at 2x plus 3 plus x minus 2. Now I'll rewrite this with the like terms. We know x, 2x and x are like terms, so we can rewrite it as 2x plus x. And then we can go plus 3 minus 2. A key thing to remember is the sign, the symbol or the sign is attached to the number on the right. Okay, just one key thing to remember, the symbol is always attached to the number on the right. So if we simplify it by adding and subtracting our like terms, we get 3x plus 1. Remember that x just has a 1 in front of it, but we never write it, so it's an imaginary 1, just number 1. We just never write it, okay? You just need to imagine that that 1 is there. Okay, so 3x plus 1. And that's how we simplify it. Well, let's look at another one. 3x squared minus 4x minus x squared plus 3x. So again, I'll rewrite it with the like terms. I've got 3x squared minus x squared. Remember, the negative sign is attached to the number or the variable on the right, minus 4x plus 3x. Well, we can simplify this now and go 2x squared minus x. Cool, so that's adding and subtracting like terms. Well, now let's look at multiplying like terms. Cool, so if we're multiplying like terms, so let's look at an example. So let's just say we've got 3a squared multiplied by 5a. Now with multiplying, they don't have to be like terms. They don't have to be together. So if we're multiplying this, we multiply the coefficient numbers. So that becomes 3 times 5. Cool. And we also multiply the powers. Cool. Now, 3 times 5 is just 15. Now with the powers, you might be thinking, well, what do we do with that? Well, we add the exponents. Okay, if we're multiplying the powers, or variables with powers, we add the exponents. So it becomes a2 plus 1. So therefore this would equal 15a to the power of 3. Now there are a few exponent rules that you could learn. They're in another video, in an exponents video. So you add the exponents. Cool, well, let's look at another example. Okay, so let's look at multiplying 2a squared multiplied by minus a b squared multiplied by 4a squared b. Cool. Again, we multiply the coefficients. So we get 2 multiplied by negative 1 multiplied by 4. And we multiply our variable. So again, we multiply all the a's together. Okay, so we've got a squared. So we'll have a squared plus 1 to the power of 1 there, plus to the power of 2. And that's also multiplied by b. So there's no b over there. B to the power of 2 plus 1. Now we can simplify this. So 2 times negative 1 times 4 becomes negative 8. And it becomes a to the power of 5 if we add the exponents, and b to the power of 3. So that's how we simplify expressions by multiplying. And one last one I want to cover is multiplying with power of powers. Okay, so if we have power of powers. So let's say if we had 2x squared to the power of 3. Cool? Just a simple one. Well, we can rewrite this as 2x squared multiplied by 2x squared multiplied by 2x squared. Cool? Just get rid of that top part there. Well, then we can just multiply this across. Well, 2 times 2 times 2. 2 times 2 is 4. Multiply that by 2 again. Becomes 8. Then we've got x squared multiplied by x squared multiplied by x squared. Well, that's x. 2 plus 2 plus 2. Well, that equals 8x to the power of 6. Cool? Let's look at one more example. Cool? Let's look at 3x squared over 2. We can rewrite that as 3x squared multiplied by 3x squared. Well, again, 3 times 3 is just 9, and x squared multiplied by x squared is just x2 plus 2, which is x to the power of 4. Okay, and one more, we normally see these things with square root symbols. Okay, square root symbols look like this, and let's just say if we have something like this, 4x squared y to the power of 4, and the square root of that, well, we can rewrite it as the square root of 4 multiplied by x to the power of 2 divided by 2 multiplied by y to the power of 4 divided by 2. Now, the reason why it's 4 divided by 2 is the square root symbol I write on the side over here is pretty much saying some variable to the power of 1/2. Okay? Now, if we rewrite our square root symbol, okay, so for example, x squared, we multiply that by 1/2, so which equals x to the power of 2 over 2. Oh, in terms of the y to the power of 4, we rewrite that as y to the power of 4 to the power of 1/2, which is y to the power of 4 over 2. Cool? So it's a pattern. So we can rewrite this now. Square root of 4 is just 2, and then x to the power of 2 over 2 is just x to the power of 1, and y to the power of 4 over 2 is y squared, and your answer becomes 2x y squared.